Welcome to this video. In the previous videos, we talk about the linear regressions based on the residual plots, LSRLs. In this video, I want to look at it differently, which is by looking at the computer printout. And the goal for this video is to help you to look at the computer printout, be sure to know how to interpret them in your own language, satisfy the stats rule at the same time. So let's begin. Reading Minitab linear regression output. Consider the scenario right here. Professor swims 2,000 yards regularly. Here are his times in minutes and his pulse rate after swimming in beats per minute for 23 sessions in the pool. So here is the computer printout given to us right here. And pause for a second or just read by yourself. See how many values or how many variables we want to pay attention to in this case. I think most of you said 3, and that's correct. Because what we really want to focus on is the constant, which is also known as A value, B value, and R squared. The other values, we can just ignore them for a sec right here. And the regression equation is also provided to us right here, which is nice, but not every cases they will give it to you. So if they didn't give to you, you're just going to find the constant and the B value, plot those values in, and make sure that you write y hat instead of y. So let's take a look at the first question. Find the LSRL for the data. The nice thing about this is that they already give to you the equation, so you can just copy it right here. Part B is interpret the slope in context. Well, what is the slope? The slope is this value, which is negative 9.6949. And that simply means for every additional minute in swim time, the predicted pulse rate decreased by 9.6949 BPM, or beats per minute. Part C, identify and interpret R squared. R squared is 55.65%, and when you convert percentage to decimal, make sure to move the decimal point in front by 2 places. But when you want to interpret it, you will say 55.65% of variation in pulse rate can be explained by this model. Part D, identify and interpret the correlation coefficient. The correlation coefficient is R. So what you can do is taking the square root of R squared, and then you will get the value. But be very careful here. When you're taking the square root of a value, you will get positive and negative answer. So you will get 2 answers. Which one should you use? It's based on the scenario. In this situation, we know that the B value is a negative number right here, which means that the whole data is a negative correlation. So what you want to do is put a negative sign in front of your answer to make sure that your correlation coefficient is a negative number. So how do we interpret it? Well, there's 3 main components we want to include in our explanation, which is the correlation moderate, strong, or weak? Is it positive or negative? Is it linear or nonlinear? So based on R squared, which is 55.65%, this is a moderate relationship. And we know because this is a negative, here's a negative sign in front of the R, this is a negative relationship. Because it already given to us the regression line as a linear model, we know it's a linear relationship also. So we will say there is a moderate, negative, and linear relationship between time to swim and pulse rate. So that's the 4 parts for the FRQs that will asking you frequently about the computer printout, like interpret the results. So let's consider another example right here. An educator wants to determine whether students' exam scores were related to revision time. For example, as students spent more time revising, did their exam score also increase, a positive relationship, or did the opposite happen? The educator also wanted to know the proportion of exam score that revision time could explain, as well as being able to predict the exam score. The educator could then determine whether, for example, students that spend just 10 hours revising could still pass their exam. Therefore, the dependent variable was exam score, measured on a scale from 0 to 100, and the independent variable was revision time, measured in hours. So here is a scenario I found from this link. It doesn't really matter. What we want to focus on is the computer printout right here. So first, as same as previous one, pause for a second and read through it by yourself to see if you can find any useful information from this printout. First of all, it gives you a regression equation as the above question. And the predictor, the constant, and the revision time, those are the two values we want to focus on, right? And r squared is also the value. All of the other things we don't want to pay attention to at this moment. So those are only the three values we want to focus on. So let's take a look at the questions. Part A, find the LSRL for the data. Well, it's pretty nice. It already gives you the equation, so you can just copy it down. Remember to change y to y hat because this is our predicted value. Part B, interpret the y-intercept in context. Woo, it's a new question. We haven't interpreted y-intercept. We only interpret the slope. So here's a new question in here. So how will you do it? The y-intercept is for 0-minute revision time, the predicted exam score is 44.5. So you can also do it in your own words, but basically I'm just saying numerically, if the x value is 0, then the y value is what value? Part C, find the correlation coefficient and interpret it. So same thing, we want to find r. We can just take the square root of r squared, finding the value. And because this is a positive relationship, we can just keep the positive answer for this. So there is a positive, strong linear relationship between revision time and exam score. Why is it a strong relationship? Because take a look at r squared right here. R squared is 72.8, which is already strong enough. And also the r value is also like, we don't want to pay attention to r value. We just want to see if r squared is close enough to 1 to make us make the conclusion that is it a strong relationship or not. And in this case, it is. So we will just say a strong relationship. Part D, find the predicted exam score for a student who revised their exam for 20 minutes. So in this question, what you simply can do is just put the 20 into the x value, right? Like replace x with 20 and finding the value in your calculator. Simple as it is, right? It's not that hard. Okay, so I will leave a question for a kind of after class practice for you just to try by yourself, like in here. So if you want to do it, feel free to do it and leave your answers down in comments. If you have any questions, feel free to reach out to me in comments, and thank you so much for watching. I will leave my stream in here for a minute and hope you have a great day.